Hello everyone, welcome to our today lecture. In our today lecture, we are going to discuss that what is an ARIMAX model. So basically, ARIMAX model stands for autoregressive integrated moving average with exogenous variables. And basically, it is the extension of the classical ARIMA model. So in our today lecture, first of all, we will be discussing it theoretically. Either it can be applied on time series data, on panel data, or on both time series and panel data. That then we will be discussing what are the assumptions for applying the ARIMAX model. Then we will be applying and taking the practical data, and we will be interpreting the results of ARIMAX model. So the next thing is that what is this AR, I, and MAX stand for? So this part of AR stand for autoregressive. So autoregressive means that you are including the lag of your dependent variable. So when your dependent variable is depending upon the previous value, then you include the AR. So that is why it is called autoregressive, because this model is including the lag of its own dependent variable. And here I mean integrated. This component involves differentiating the dependent variable to make the time series stationary. So if your data set is not stationary, then it will convert into stationary. And then this is MA. MA mean moving average. This component involves modeling the error term as a linear combination of past error terms. And then comes the X. X mean exogenous variable. These are external variables that are hard to influence the dependent variable. These variables are not part of the time series itself, but can help in predicting the dependent variable. So here is the basic econometrics for the general equation for ARIMAX model. YT. So here YT means the dependent variable, and C is the constant term or the intercept, and this theta here or the phi sign. The phi sign is the coefficient of the autoregressive. Here you can see that YT is our dependent variable, and we have included the lag of dependent variable. So YT minus I, that is the coefficient of the dependent variable lag, and this theta is the coefficient of the moving average, and ET is the error term, and this BK here is the coefficient of the exogenous variable, and XT are the exogenous variable, and ET is the error term. So this is our basic or generic equation for the ARIMAX model. And then question comes that can we apply ARIMAX both on time series and panel data? So no. So yes, we can apply ARIMAX on time series data, but in case of panel data, we cannot apply ARIMAX model directly. So as standard ARIMAX is univariate or one dependent variable. So for panel data, you can go with these options: pooled ARIMAX, fixed effect ARIMAX, or dynamic panel ARIMAX, panel var, or PVAC. That all the tests we have already discussed in our previous lectures. So so far time series data you can apply the ARIMAX, but for panel data you cannot apply ARIMAX directly. So what are the application of ARIMAX model? So in case of economic forecasting, where external factor like interest rate, inflation, or other macroeconomic indicator affect the time series. And in case of weather forecasting, there are some external variables like environmental variables, temperature, humidity influence the prediction. And in case of marketing analysis, where advertising spends or other marketing efforts impact sales trend over time. So that why in both of these three data sets, ARIMAX model is useful. So next comes the assumption for ARIMAX model. So first assumption of the ARIMAX model is that the model should be linear in terms of variables. So the relationship between the dependent variable and the independent variable or exogenous variable is assumed to be linear, and the data should be stationary. The time series data should be stationary. If the series is not stationary, differencing or the transformation may be required to achieve stationarity. So if you feel that your data set is not stationary, first of all, you have to convert your data set to stationary, either by taking first difference or taking by growth rate or by taking log or making the transformation of your data set, then you can apply the ARIMAX model when it is converted to stationary. Then next assumption is independence of error. The residual or from the model should be independent of each other. The error must not be correlated with each other. In other words, there should be no autocorrelation in the residual. This ensures that the model has captured the time-dependent structure in the data. So in our later, in this section, we will be seeing that either there is an issue of autocorrelation in our data set or not. The next thing is homoscedasticity. The way the variance should be constant over the time period. So the homoscedasticity means the residual should have a constant variance over time. This means that spread of the residual should be uniform across all levels of the dependent variable. Normality of the errors, while not strictly necessary, normally distributed residuals can make the estimation of parameters more robust and the interpretation of statistical test more straightforward. So here we see that there is a relaxation in case of normality of errors. So if errors are not normally distributed, so still we can apply ARIMAX and it will give you the optimum result, but in the best case it should be more appropriate that your errors are normally distributed. The next thing, exogeneity of the variable. The exogenous variable included in the model should be truly external to the dependent variables process. This means that they should not be influenced by the past value of the dependent variable. So it means that your previous or lag value of your DV should not be affecting the IVs. So take your IVs in such a way by looking at literature view and by applying some econometrics technique to identify that either there is a relationship between your IV or your lag variable or lagged term of your dependent variable. So now let's go to EViews environment, and then we will be applying the ARIMAX model, and then we will be interpreting these results. So now first of all we have to open the EViews. Here you can see that I have opened my EViews. Then you have to bring your data set into EViews. So I have copied my all data set. I have three variables, GDPG, inflation and FPI, and my data span is from 1970 to 2024 and it is time series data. So then go to file, new, then work file, and now paste your data set here. Then go to quick, empty group, and paste data set here. So now here you can see that all of our data set is now present here. So now select your dependent variable first, then press the control button, then select all of your variables, then right click, open as equation. So now here you have to write the ARIMAX model. So GDPG C, then constant, AR1, then FDI, and the lag of FDI. So this -1 is here showing that we are taking the lag of our independent variable, one lag. So -1 means we are taking one lag. If you want to include more than one lag, like 2 or 3, you have to enter here 2 or 3. Then press OK. So now here you can see that it has given us the result for ARIMAX model. So our dependent variable is GDPG, method ARIMA maximum likelihood, and sample size is from 1961 to 2014. Number of observation are 54. So this is our result. So now we will go again to PPT and we will try to interpret the results. So now here you can see that first of all we will be explaining the result of this R square. As you can see, the R square value is 0.40. So basically R square explains that how much variation in the dependent variable because of our independent variable. So it is indicate that approximately 40.21% of the variation in the GDP growth is explained by the model. This is a covering more than 5 decades, as my data set is of 54 observations, so it is including more than 5 decades data. So especially considering the inclusion of only a small number of economic meaning variables and the natural volatility of annual growth rate. So as you can see that we have included only two independent variables, so that's why R square value is very much low. Then comes the adjusted R square, this one. Adjusted R square value is 0.3 to confirm that after accounting for degree of freedom used by 6 parameters, the model still explains roughly 32.6 of the variation, a clear improvement over simplest specification and evidence of meaningful signal extraction. Then comes the AIC information criteria. So this is used for taking the lag. So AIC is 4.83 and Schwarz criteria is 5.148, remains competitive, indicating that the model strike a good balance between fit and parsimony. So basically these two are used for deciding the optimum lag length criteria, and if you follow this you have to apply OLS again and again, and then you will see the results. At the result which the AIC value is at minimum, at that you decide that how much you are going to take lag in your model. Then comes the F statistic value. F statistic tell you the joint significance of the model, and the T statistics tell you the individual significance of each variable. So if the F stat value is less than 0.05, so it means your overall model is good fitted. So as in our case, our probability value is 0.00, provides very strong evidence that the model as a whole is highly statistically significant. So if the probability value of F stat is less than 0.05, so it means the overall model is good fitted. Then comes the Durbin-Watson test. So basically Durbin-Watson test is used to detect the issue of autocorrelation. If its value is between 1.5 to 2.5, then there is no issue of autocorrelation. As my value is very near to 2, so it means that there is no issue of autocorrelation in our dataset. Then comes this inverted AR root. So inverted AR root is 0.13, and if the value is below than 1 in absolute value, confirm that the autoregressive part of the model is stationary and stable. So it shows the stability of the model. So as our value is very much lower than the 1, so it means that our autoregressive part of the model is stationary and stable. So next thing is that this part of the table, where we can see that here we can see the value of C means the intercept. So intercept shows the average value of the dependent variable when all other variables are 0. So as its value is 5.46 and it is statistically significant because its probability value is less than 0.05. So the intercept is highly significant and positive when all exploratory variables FDI and inflation and the lags are 0, and after accounting for AR dynamic, the model implies an unconditional mean growth rate of approximately 5.74 per year. So basically intercept shows the average value of dependent variable when all other variables are 0. So the next thing is that FDI, which is our first independent variable, its coefficient sign is negative, so it means that FDI at current point of time is showing a negative effect with the GDPG, and FDI minus 1 is the previous value or the lag of FDI that is showing positive effect with the FDI, and both are showing statistically significant. So FDI coefficient is minus 1.85 and probability value is 0.02, that is current period foreign direct investment. Except a statistically significant short-term effect on GDP growth. A 1 percentage point increase in FDI as a percentage of GDP is associated with an immediate reduction in growth of GDP. Why reduction? Because FDI at current point having a negative relationship. So this is because the short-term adjustment friction, crowding out of domestic investment, profit repatriation outflows, or import intensive capital good installation. So there might be some other reasons according to the country, and it varies from country to country and environment. Then comes the FDI lag. FDI minus mean the lag of FDI with respect to previous period. So it is again it is showing a positive effect with GDP, and it is also significant as its p value is less than 0.05. So FDI minus 1 or FDI lag coefficient is 2.44, probability value is 0.01. The lagged FDI term is positive and statistically significant at 5% level. 1 percentage point higher FDI in the previous year raises current GDP growth by approximately 2.45. So this strong lag positive effect captured classic FDI spillovers, technology diffusion, improved management practices, supply chain integration, export capacity building, and learning by doing effect that typically materialize with a delay. So the next interpretation for inflation current value and inflation lag value. So in case of inflation at current value, we observing a negative relationship that it is affecting our dependent variable in a negative way, while in case of lag it is showing a positive relationship with the dependent variable. So inflation coefficient value is minus 0.43 and its probability value is 0.00, that is highly significant. Current inflation has a very strong negative and highly statistically significant impact. Each additional percentage point of inflation reduces contemporaneous GDP growth by 0.43 percentage point. This result aligns with extensive empirical literature showing that inflation creates uncertainty, distorts price signals, reduces real investment returns, and erodes purchasing power, all of which harms growth in the short run. Then when we look at its lag value, it is showing a positive impact and it is also significant. Lag inflation enters positively and significantly. A 1 percentage point higher inflation in the previous year is associated with 0.37 percentage point higher growth rate in the current year. This may reflect policy accommodation, wage indexation, catch-up demand recovery following inflationary periods, or the fact that very low inflation can sometimes signals weak demand that later rebounds. Again, it's vary from country to country. And then comes the AR1. Its value is positive and it is statistically insignificant as its probability value is greater than 0.05. So AR1 coefficient 0.12, probability value is 0.43. The autoregressive term is positively but statistically insignificant. This indicates only weak and non-significant persistent in GDP growth once the effect of FDI and inflation are controlled for. In other words, growth shocks tend to dissipate relatively quickly rather than exhibiting strong inertia. So this is all for the interpretation of these independent variables and AR1, and then when we look at sigma scale, it is also positive and it is showing statistically significant relationship. So when we look at key economic insight, FDI exhibits a clear J-curve pattern, an initial negative impact followed by a strong positive lagged effect. This is textbook's evidence of adjustment cost followed by productivity and spillover benefits. And in case of inflation, inflation is ambiguously harmful in the short run, but the positive lag coefficient suggests that the economy partially adapts or that moderate inflation can precede demand-led growth. And for policy recommendation, for FDI, policy accept short-run growth cost as part of attracting high-quality FDI, prioritize greenfield projects, export-oriented manufacturing, and technology intensive investment that generate the strongest lag spillovers. Implement robust screening, performance requirements, local content training, R&D, research and development, and after investment support services to accelerate and maximize the positive phase. And in case of inflation control, price stability should remain a core macroeconomic objective. Even moderate inflation has a clear negative contemporaneous growth effect. Central bank independence, prudent monetary policy, fiscal discipline, and supply side reforms, energy, agriculture, logistics are high return intervention for sustaining high growth. Again, these are the policy recommendation according to my country, according to my result, according to my scenario. it is not necessary that you must follow these policy recommendations. I am telling you this because when you are doing your research, your thesis, your projects, you must have to provide the policy recommendation. So in today's lecture, I am also covering that how to write a proper article, proper research paper, proper thesis, that you have to give your policy recommendation based on your results. Then for macro stability and shock management, the weak and insignificant AR1 term implies that growth does not strongly self-perpetuate. This places greater responsibility on active counter-cyclical policies and shock buffer, foreign reserve, flexible exchange rate, fiscal space to prevent growth collapses and capitalize on upturns. So long run growth potential, the highly significant constant term suggests that structural growth rate around 5.5% when FTA and inflations are neutral. So it is the basically intercept that shows the average value of the dependent variables when both FDI and inflation are 0. So FDI inflows could realistically push average annual growth towards 6 to 7% over the medium to long term. So next is that we want to see that either our residuals are correlated or not. So I have already pasted my result here. So we will again go to EViews environment, and then we will be applying autocorrelation test as well, and then we will be seeing that our residuals are autocorrelated or not. So here you can see that we have these results when we apply ARIMAX model. Then we go to view and we go to residual diagnostic and then go to parallelogram squared residuals. So it is asking about lag. So we are going with the default option of lag to include 28. So now here you can see that it has given us the result. So as you can see that I have copy pasted my result here. So now look at these results and we will try to interpret it. So now for the our desired results, these columns must lie between these bars must lie between this confidence interval. So if your bar lies between these critical region of the dotted line, so it means that there is no autocorrelation in your data set. So as you can see that all of our bars are lie vary in between these critical values. None of these bar exceeded this value. So and you also can interpret by looking at the p values. So p values must be greater than 0.05. So you can see that all of our p values are greater than 0.05. So indicating that there is no issue of autocorrelation in our data set. And this thing was also tell us by the Durban-Marsan test, and that also shows that there is no issue of autocorrelation in our data set. So the next thing is that we have to see that our residuals are normally distributed or not. So null hypothesis is that residuals are normally distributed, and alternative hypothesis is residuals are not normally distributed. So we again go to EViews, then go to view residual diagnostics, and click on histogram normality test. So as you can see that it has given us the histogram result and as well as York-Berra results. So we go again to our PPT file where I have already pasted my results here. So we have to look at this p value. As the probability value is less than 0.05, so we have to reject the null hypothesis. So what was our null hypothesis? Null hypothesis was that residual are normally distributed, but our probability value is less than 0.05, so we have to reject this and accept it. So basically it concludes that our results are not normally distributed. So the next thing is that we want to check that either our residuals are homoscedastic or heteroscedastic. So variance is constant or not. So for that I have already copied my result. So but we will practice it again. We'll go to view, then go to residual diagnostics, and then click on heteroscedasticity. So by default it has selected the Brosh-Pagan Godfrey test. So we are going with this option. So go with this option and click on OK. So now here you can see that it has given the result of Brosh-Pagan-Godfrey test, or simply we name it as BP test. So the null hypothesis is that homoscedasticity, that variance is constant. So now go to PPT and we will see that how to interpret it. So now you can see that null hypothesis is that residual are homoscedastic, or we can say that variance is constant, and alternative hypothesis that residuals are not homo. So we have to see the observed value and its p value. We have to see the p value of observed R square. So this value 0.18. So as our p value is greater than 0.18, so we have to accept the null hypothesis. And when p value is less than 0.05, we have to reject the null hypothesis. But at the current moment, our probability value is greater than 0.05, so we have to accept it. So by accepting the null hypothesis, we can conclude that our residuals are homoscedastic, so it means that our variance is constant. So that is all for our today lecture. So this is how you can apply ARIMAX model, and this is how you interpret its results. So if you have any query, any question regarding our today lecture, you can ask me freely.